Hi, welcome to another video. Today I'm going to walk through a Connect 4 game that I built using Python and Pygame. This project is based on a procedural program version of Connect 4 I originally wrote while I was studying. Since graduating, I decided to refactor it into a clean object-oriented architecture using the model view controller pattern. This refactoring process demonstrates my ability to recognise code smells, apply design patterns and improve code maintainability. We'll start with the project's structure before we get onto the code. So originally it was just one file in the procedural program. So with refactoring I've got a file that has all the constants on. Then the file for the model, which handles the game's logic and the data. And this is the Pygame view. This manages the visual displays and user interface. And the controller is the last one, and that coordinates between the model and the view. So as I said, everything was all on one file, and so I separated them out into separate files. It was easier to understand what the code was doing then, and then changing any features wasn't so complex and less chance of breaking the game's logic. So that's why I use the model view controller pattern. So it also makes the code more maintainable, testable and scalable. And it's a good example of how refactoring can transfer working code into professional quality code. So we'll start with the code now. The first one will be the global constants file. You've all defined all the magic numbers and configuration values. In the original procedural version, these were scattered all through the code as magic numbers, etc. During refactoring, I extracted them into this dedicated constants file. This demonstrates the try principle. Don't repeat yourself. Now the game is easily configurable. If you want to change to a bigger board, just change values. Or if you want to change the colours, you can sort of change them as well. So now for the Connect 4 model class, this is where all the logic for the game lives. Start off by creating a board with 6x7, and it's represented as a 2D list, and the zeros represent empty spaces. So with the methods through here, we've got the print board, creates the board. Then we've got the drop disk method. This finds the last available row in the column and places the player's disk in there. And after that, this valid column. This is to check that the column isn't full of disks already, so they can actually drop a disk in there. And the winning move, and the get next open row, so that's sort of when the disk is dropped and it finds the lowest row for that column. Then move on to the winning move. This looks at both any line of 4 discs being lined up with the same colour in the horizontal, the vertical. Also an upwards diagonal of 4 or a downwards diagonal. An error with the view. Sets up Pygame and sets the font and the size of the font that we're going to use, and it creates a screen. You can go and draw a board, which we put the background on first, and then draw the blue part of this game, and then we go and put the background colour in this circles where the discs will fall into or drop into. After that, we'll draw the discs for each player, where they've dropped their discs, and it's just sort of updates each time a move is made. Go on to clear the top area. It's efficiently clears just the top portion of the board where the preview discs appear, rather than having to redraw the entire screen. And we've got Windows Update and Update Board. These handle the display refresh calls to Pygame, and they're separated for clarity and potential future optimization. Then we go to the win conditions. If player 1 wins, player 1 will be printed across the top of this game, or in the preview area of the game. Or if player 2 wins, player 2 has won. And here's the go method. So we've got here, and the 3 types of events that we've got in here. This is the quit, so at the end of the game it cleans the shutdown of the game properly. We've got the mouse motion. This is to move the disc across in the preview screen, so you can move the disc across to select what column you want to drop it into. And then the mouse button down event, and that drops the discs into the column you want it to go to. And down the bottom here, you switching between players. We use NextOR operator, which toggles between player 1 and player 2. And there's also a delay of 5 seconds after the game has been won. There we've got the controller now, and it creates instances of both the model and view. And then there's the run method that sort of gets the game going. So, winding things up, this Connect 4 game implementation demonstrates my ability to recognise when code needs refactoring and execute that refactoring systematically. So, wrapping up, this Connect 4 implementation demonstrates my ability to recognise when code needs refactoring, my ability to transform procedural code into clean, object-oriented architecture, implement design patterns like MVC to solve real organisational problems, handle user interface and graphic programming, and follow software engineering's best practices. The journey from a working but messy procedural program to a clean, maintainable code base shows not just my coding abilities, but my commitment to code quality and professional development practices. Thanks for watching, and feel free to check out the full code in the description below.